Hello man, I just came all the way from New York. I'm from New York. They taught me something new. I'm here to teach you guys the same thing now. So they taught me vectors and scalar quantities under physics. So we'll be learning this today. So just pay attention and follow me. I'm in New York now. Follow me. So in physics, I know that you guys all learned what we call scalar and vector quantities. Now I want to be going details into it under physics 101. So vector quantities are those quantities that gallant, they have weight, they have magnitude, but they have magnitude and they both have direction. They have magnitude, they have direction. But scalar in the other way has only one, which is that's magnitude but no direction. For instance, I'll give you an example. Your mass. You can weigh 40 kg, you can weigh 50 kg, you can weigh 50 pounds. But that 50 pounds, is it going due east, is it going due west, is it going due south? Does it have an angle? No. It has no direction. So mass is fundamentally what it is scalar quantity. But I can give you an existence velocity. I'm going to 45 kilometers per hour due east. Now, the magnitude is there, which is 25 kilometers per hour. And the direction is there, due east. I'm going due east. Are you following me? Follow me. So I'm going to list some scalar quantities, going to list some vector quantities, then I'll go into calculation aspects. They just follow me. So some vector quantities like displacement. Displacement is distance in a specific direction. Distance covered in the specific direction. We have velocity. We have acceleration. Here you have your mass, like I said. Here you have time. Time has no direction. Here you have speed. Speed has no direction. You have distance has no direction, and so on and so forth. It still continues. So I'm going to how do we resolve vectors? How do we resolve vectors? How do we resolve vectors? How to resolve vectors? Now we'll be talking on this now. How do we resolve vectors? How to resolve vectors? How to resolve vectors? So if a vector is moving in this direction, 5 Newton. Another vector moving in this direction, 7 Newton. And I ask you, find the resultant. Whoa! This question is a very hard question, man. It's a very hard question, man. So, what do we do? You see these two, they are going this way, they are going this direction, they have a specific direction. And we still have magnitude that defines vector quantity. So this is a vector quantity. So for you to find the resultant, if they are moving towards the same direction, not you add them. But if they are moving, one is going quickly, the other one is going quickly, you subtract. Come on, follow me. You subtract. So the resultant here will be 5 plus 7, which is 12 Newton. How about following me, man? You're following me. I want you to tell me, man. So, what if one is going this way, 7 Newton, another one is going this way, 5 Newton? What will be the resultant here? I told you that if they're going like this, you subtract. So, the resultant 7 minus 5 is what? 2. Where will the direction be? Where will the result of direction be? Will it be like this or will it be like this? My dear brother and sister, it will go like this. Because that's where the highest magnitude is, right? 7. So it will be resultant is equals to 7 minus 5, which is 2 Newton. Okay, follow me. Okay, follow me. So the next scenario is when the next instance is when the two vectors are connected by 90 degrees. Are connected by what? 90 degrees. For instance, I have a vector going due north. No, this north. I mean, you guys know this north. You guys know this north. And another vector going due east. North, east. And maybe this one is 3 Newton, and this one is 4 Newton. I know that there's an angle here, and this angle is what? 90 degrees. I can call it vector. Let me call this vector N, and let's call this vector E. Vector N is perpendicular to vector E. That means they have 90 degrees between them. Perpendicular. They have 90 degrees between them. So I will ask you, find the resultant. Find the resultant vector. what do? You draw a line here. So this line is automatically parent is also automatically equal to this line. If here is 3, here is also 3. And this is the result. This is the result of arrow. This is the arrow I'm looking for. According to one great mathematician, I once talked to him. His name is Pythagoras. He told me that. He sat me down and said, yo boy, to solve this problem, it will be arrow square. Arrow is what? In this triangle, arrow is the hypotenuse side, man. The longest side of the triangle. Is equals to the opposite side. The opposite side is what? This side. This is what the angle will be facing, theta. 3 square plus 4 square, which is arrow square, is equals to 9 plus 16. Arrow square is equals to 25. Arrow is equals to square root of 25. Arrow is equals to 5 unity. As simple as that, you know. It's very simple, man. Very, very simple, man. So we have gotten the arrow, the result is 5 Newton. So the next step is to find the direction of the direction. The direction. So we're looking for theta. So now you all know what we call SOHCAHTOA. SOHCAHTOA. Sine opposite of our hypotenuse, cos adjacent of our hypotenuse, tan opposite of our adjacent. So this is our hypotenuse, this is our opposite, and this is our adjacent. So I'm using tan. Then this is the shortest of all of them. I will say tan theta. This is theta. Tan theta is equals to opposite over what? Adjacent. That is about 3 over 4. Theta is equals to tan inverse. This will give you 0.75. I think the first calculator you'll get something like 30 something, point something. So I want to get the answer, put it in the comment section for me. So I will take it, I'll stop here, man. So in our next class, we'll be talking about how to resolve vectors using parallelogram law of vectors. Like for instance, now this is when the angle between them is 90. What if when the angle between them is less than 90 or it is greater than 90? That is where the parallelogram law of vectors comes in. So in our next class, just subscribe, stay tuned, you'll get more updates. See you.